Here's, all right, one of my favorite questions of this class. Let's see, what have we done? We've done the two constructors, deconstructor, get length, append. We did print. We have not done insert or remove, and we did the other two. Wow, we've done most of this first half of your lab for you. Oh, only the first half. Which would you like to do, insert or remove?
Remove. Insert.
Insert.
Insert, remove, anyone? I'm going to leave it up to y'all. How do you want to decide this?
You can do insert. That's fine. Both.
Then, if you choose both, I will do neither.
No, it's fine. Insert.
Insert? All right, we'll do insert. Oh man, look at all this code we've been writing.
Thank you.
You're welcome. All right, we want to insert at a given position this value. Okay, what do we need to do first?
Rover. Rover.
Okay, sure, we can do rover.
Get a rover.
Start with the rover. Where's rover start?
In header.
M head. All right. How many times do we need to increment rover?
Last time.
And how do we do that?
That's
Ooh, that was weird. All right, now what do we need to do? So first, we get rover to the position. All right, so we've incremented that many times. Interesting. Where's our correct? All right.
Oh, we need to create a node, don't we?
Oh yeah, we need to create the node. Yeah, really do, don't we? So val equal to the value passed in. Ooh, that was bad. And it's good programming practice to set mNext equal to null, at least at the beginning. All right. Create the new node. All right. Okay. So let's go back to our picture. 8. Put a 19 right here. We'll end it. And we'll say we're doing insert on, I don't know, 1, the value is 34. So, new node. In other words, we want at position 1, so 0, 1. We want that position to be 34, which means 8 and 9 are going to be shifted down. So I'm going to go and put the new node right here. 4 pointing to nothing. So that's what we have right now. When we execute rover, let me move new node somewhere else so it doesn't get in the way. So new node's right there. Rover we're going to have started head. Awesome. Then we're going to move it how many times? Pause times, which means that rover will now be pointing here. Okay. So how do we get this node to be right here?
Just have the rover point to the new node instead of that position.
All right, well, if we do that, then rover's going to point here.
And then the next, and then
you've lost all your links to the whole list.
One, okay, so.
We don't want to do that.
We need to move the other, point it down and point it down.
Point what down?
The M next.
Who's in next?
17.
Rovers, okay. Well, yeah, we do want to point rovers next, but what he's saying is rover dash M next is going to equal what?
You know.
All right. All right, what is that going to do pictorially? So that's going to take this link right here and have it go right there. Oh, is that what we wanted to do? No, what did we want to do first? We want that to go where?
To the 8.
Which is
Rover.
rover. All right, so let's do that first, because that should be a low-hanging fruit. All right, so then that's going to update this link to go here. All right, that's good. Good so far. But what else do we need?
Shouldn't the head go down to the?
All right, the head would want to go here, but if this list was longer, it may not be head. Head might be way back there. So how are we going to go here? Can we go here from over here?
Yes.
How would we do that?
We need a previous.
We need a previous. Okay, let's do a previous.
Do like what? Pause minus 1.
Oh, we can do pause -1. I like that idea better, actually.
Yeah, that is better.
All right, so pause -1. So we decrement pause, and we're going to have to revisit this line of code, because that changes what that does. All right, so let's back this out. This is null. Pause -1 means that rover is now going to point to the node that's previous to where that thing needs to pin. All right, what do we need to do next?
Now we need to set rover's index to the new node.
All right, so if we do this first, we get rid of that link. Is that what we want to do first? No. We want to update this link first. So we want new node to equal what? New node's mnext to equal rover's.
Rover's index.
Yeah, I think you said it. Yeah, I was pretty sure you did. All right, so actually the update of this code's not too bad. So new node.mdex equals rover-mnext. So new node's mnext, that's this thing, is now going to point to rover's mnext, which is that guy. Is that what we wanted?
Yes.
Perfect. Now what do we do?
Now we need to get rover to point to the new node.
So how do we do that?
Rover equals
Rover, not rover equals, but rover's
value. Pointer.
pointer, which is
And next.
mnext. Been saying it so long, it's been
Yeah.
tongue twisting now. All right, so we want to do mnext equals this guy. All right. Is that it? So, I mean, is this what we want?
Yes.
All right. Is there anything else we need to do with the code?
Pause.
We need to update the.
Size.
Okay. Is this code correct? That was a dangerous question. Let's go write some test cases. Hmm?
No.
Oops, wrong thing. All right. Okay, so let's do to sl.insert. Well, if we haven't done anything, so let's insert 0, the value 17. Right? And then we should be able to do ts assert equals sl sub 0 and the value 17. Right? Oh, sec volt. Well, that failed miserably. What happened?
We don't have anything for the lib list is empty.
Yeah, so should we test that separately? Oh, this needs to return true. Oh, look at that. Okay. All right. So if
Didn't hit it at all.
I'm gonna make this easy.
Oh,
All right, if mhead's null, let's just call append. We already wrote the code for that. We don't need to write it again. Unless you want to write it again, Matt.
no.
No? Okay, good. Got to use your resources. Hey, look, it passed that time. Well, that was a good first test. All right, let's go ahead and put 119, and then we'll put 118, right? So then it should be, that's the way it should look, correct? Okay. Oh, look at that. Looking good. All right, your professor's evil. What is he going to do? Actually, one thing we haven't been doing is testing that the return values are correct. All right, let's make sure that that fixed.
Those are
Wait,
false.
yeah.
Yeah.
The
You got 19,
18 and 19
19.
needed to switch.
Actually, I need to do this because that was the original test. There we go. Much better. Whew. All right. So your professor's evil. What is he about ready to do?
Oh, no.
What should that be? False, false, and false. Seg fault. Well, that's new. What do we need to do?
I hear like an every time I see sig fault.
Yep. The computer should do that. Womp, womp, womp.
It should just blow up. Sig fault.
What do we need to test here at the very, very beginning?
It's negative.
We need to validate position. So if position is less than 0, for example, we need to return false, right? Because you can't insert something in negative position. That makes no sense. What else would be not a good position here?
We need to make sure that the position doesn't go oversized.
Right, so position is less than 0 or position is greater than m size, return false. All right, let's see what that does. Okay. So now the test cases helped us out. At least thinking evilly. Your professor will do that. Trust me. All right.
Sometimes I get so happy I just got it working that I don't worry about the evil stuff.
I'm just thinking this is gonna go 100% okay.
Yeah.
And then you submit. Oh, that's beautiful.
Yeah.
Or like last semester when everyone's like, oh, just doing it, and it's like, wait a minute, error was there. No.
Yeah!
No point.
Boom!
Exactly, and it's just like.
That's like I gotta find a good symbol for that, like haha, like hee hee, just something evil on that one, because I'm not trying to be evil there. People are going to give you null. It's
Exactly.
not
That's
just
like
me.
after the first 2 labs, you learned, okay, put something with null, and like the people that didn't, it's like, why am I getting this error?
Well, I'm the only person using the program. Or maybe I'll just say.
Terrible.
Don't put null in it.
Yeah.
Terrible assumption. Terrible
All my
assumption.
comments.
All right.
Please don't put.
All right, let me go. Okay, this is good. This is great. Showing you how you should think and do your labs. Let me go over this lab real quick. So, the first part of this lab is to complete our singly linked list implementation. Looks like we did everything but remove. Yep, so you need to do remove. Best of luck. Then afterwards, you need to do the same thing, everything we just did, but with a doubly linked list, which we will do a quick lecture on next class. Since your project's due Wednesday, I decided to give you a little extra time. It'll be due the Monday after.
This is so tight.
Monday after that one, but we'll probably be doubling up on labs because of that. But that's okay, because y'all need to get your projects done.
Yeah, thank you. I was thinking, like, man, I got 3 labs and a project this weekend.
Don't worry, this will still come back and get you.
Yeah.
Notice the last thing is some questions. What's a performance difference for append between an array, a linked list, and a doubly linked list? So we're going to have to think about the big O. How about for insert between the different ones? For the operator subscript, the remove, the search? Ooh, we haven't done search, but I just want you to answer that question. Make sure you put this in a text file or somewhere obvious for us. And then, yeah, you may answer in the comments of your code in a separate text or doc. Any questions on this lab?
The auto grader isn't going to make sure we have those correct.
No. No. I will have to go in and inspect that.
So, this lab and another lab will be due the following Monday, and another lab will be due Wednesday.
Yeah,
Just like to keep everything straight.
no problem. Any other questions? All right. Hang on, guys, before I say lab time.